Hi everyone, how's it going? Welcome to another week of sound design for new media. This week in this video we're going to be talking about intentional and consequential product sounds. And by the end of this video you should be able to identify both intentional and unintentional sound designs. You should also be able to understand exactly why they would be used in different particular scenarios to achieve desirable outcomes. So let's start by looking at two examples of products. Here we have a Harley-Davidson Sportster motorcycle and a Samsung microwave. Now the Harley-Davidson motorcycle is a very consequential sound design object. It has a very particular sound. In particular, the engine sound of a Harley-Davidson motorcycle is very idiosyncratic. It is unique in its sound. In fact, so unique that Harley-Davidson attempted to claim the intellectual property of that sound by patenting it. Now, they didn't manage to do that. They were unsuccessful in their attempts to patent the sound of their engines, but it is such a feature of their company, of their branding identity, that they actually perceive it as something that has such value that they would want to own it commercially. Now, this consequential sound, what is it? Why is it consequential? The engine exhaust sound is produced as a byproduct of the mechanical design of the engine itself. So consequential sounds are those that are produced through the actual engineering of the product. We can think here about clasps clicking and snapping. We can think about the opening of a bottle as a mechanical effect produced through the design of the bottle itself. But consequential sounds are sounds that are produced through the fundamental engineered structure of a product. And an intentional sound is something that has been added, usually through electronics, usually through some kind of speaker, and usually through some kind of digitization or computational process. And so an intentional product sound example would be a Samsung microwave. It has a chime to let you know that it's done. It has sonic feedback to let you know when a button is pressed. But neither of these sounds are actually necessary for the functioning of the object. They're actually added intentionally to provide feedback to the user of the object. So two different kinds of sounds, intentional and consequential. Now, consequential sounds, they're obviously everywhere. Consequential sounds are deeply connected to kind of value judgments about objects as well. And we all know this, both the feeling and weight of an object and its kind of material design, its materiality, as well as the sounds that it makes actually produce all kinds of different effects on the user. And so a simple model of this is that sources, as in products themselves, have transmission processes in a product, and that might be through the mechanical design of an engineered product. They have a radiation process, how they're actually transmitted through that product, and a transmission to the receiver. And so if we apply this to the example of the motorbike, we have the engine, we have the transmission in the product, which is through the vibrations of that engine, the actual pistons moving. We have radiation, which moves through the exhaust chamber, and transmission to the receiver through the air. Now, this is a simple model that we can follow to kind of create or generate consequential product sounds, but here we have an intentional product sound model, and this is where we start getting a little closer to home for us in this subject, which is that an intentional product sound model follows more closely a design process. Instead of us being able to identify kind of an engineering flow, we instead approach it as a conceptual design process, where we include, for example, the experience of the user, not in the sense of whether they're going to enjoy the sound or not, but whether they're actually going to be able to use the sound in any particular way. And this requires us to do something like a problem analysis. And we kind of began to dive into this last week when we started putting together interaction flows and models. So both from a conceptual and problem design point of view, an intentional product sound brings with it a whole different range of thought processes. And this is where sound designers, when we're thinking about intentional product sounds, we actually need to start. We need to start thinking about what is the problem we're trying to solve by including an intentional sound here. And in the context of the microwave, sonic feedback about, say, when the timer is done is a really clear example of a problem that we can articulate through sound to provide feedback to the user. That's very different to a byproduct of an engineered scenario. So we have these two different approaches to sound design. One which is about the byproduct, and the other that is about solving problems or providing feedback. And so we can kind of break this down into kind of disciplines of thought, or the kind of the role that a sound designer has, a product sound designer has. So a product sound designer needs to think both about the engineering of an object, but they also need to extend the range of considerations, especially when thinking about intentional product sounds, to include things like musicology, acoustics, psychoacoustics, and psychology. And this is where we see the intersection of interaction design and sound design meet very nicely. Thinking about the experience of the user in terms of their perception, both through the way that they hear and perceive, but also thinking about the semantic meaning in terms of the psychology of the sound, become really, really important.